back if you're coming in for the second part, or welcome for the first time if you're coming in today first. My name is Venkat. I'm part of the team here at the archives at NCBS, and on behalf of our entire team, we welcome you here. And big shout out to Madan, who's sitting here, for making all of this possible, for introducing the ideas and connecting us to Anurag. And of course, big shout out to Anurag for agreeing to do this and also being open to a lot of the questions. And thank you to all of you who offered really good and interesting questions and stayed on for the refreshments afterwards. So we hope similar dialogue continues today. I'll get out of your way very soon. If you're here for the first time, I'll just quickly introduce Anurag, who was born and raised in Lucknow before graduating from IIT Roorkee in 2002. This was followed by a master's and a doctoral degree from UC Berkeley. And since 2008, he's been at IIT Kanpur as a faculty member in the mechanical engineering department. Anurag's academic interests are broadly in theoretical solid mechanics, but I'll just cut that short to say that we're going to focus today on part 2 of this really interesting work on the structural design of Indian musical instruments, historic and scientific perspectives. Part 1 yesterday was on the Tānpurā, and today he's going to be focusing on membrophonic percussion instruments, which I'm really looking forward to. So, over to you.
Thank you, Venkat. Okay, so let me just start right away. So I'm going to continue the program that I introduced yesterday in the context of Tānpurā, but shift my attention to a few of membrophonic percussion instruments, which were all, I mean, if you look at Sanskrit texts, they're also termed as avnad instruments on which were covered by stretched leather. So those are the kind of instruments that we are interested in. Okay. This in fact is one of the most distinguishing tradition that we have had as a culture, because when it comes to percussion instruments, I can safely say, based on my last decade of exposure with these instruments, that although percussion is a very common practice in almost all cultures, and percussion instruments, particularly membrophonic percussion instruments, developed in almost all world cultures. I mean, you see Africa's extremely rich variety of drums. I mean, every region of Africa has its own signature drum. Coming to all the way to Japan, for example. Japan is another culture which has an extremely rich variety of drums. But almost everywhere, drumming is a very popular activity and has a lot of connection with the social aspects of people's life, and music also. But in India, drumming is very different, and that is something that I want to run through with you. So in India, drums have been extremely integral part of our music, and music of the highest quality. And when I say so, I just want to attract your attention to, for example, for those of you who would have attended Western concerts and Western performances, drums really doesn't show up there that much. I mean, in solo concerts, drums rarely shows up. I mean, if you hear piano solo, cello solo, violin solo, drums don't show up. In concerts, they show up, and the only drum that really shows up with any respect is timpani. And I will tell you why timpani shows up. But that is not so in Indian music. In Indian music, drums have to accompany, whether it is tabla, it is pakhavaj, it is mridangam, it is idakya, it is mirav, there are lots and lots of drums. In India, we have an alternate drumming culture in the subaltern world, which is very different, which has, in my opinion, far more richness than what we usually see around us. But that is not something I'm going to get into. That is a different thing to talk about. So let me just very briefly sort of, these are also the kind of things that I'm going to focus my attention on. So there is this one family of drums, which in fact most of us are mostly familiar with, are drums which have these membranes, the stretched membranes, with a patch on it. Okay, I mean, I think most of you have seen in my first slide also, there's this surface of the tabla, so you see this black patch. This is called siyahi, and it is made of an iron paste with great care, because this is the design feature of these instruments, right? As I have been focusing on the central design feature of instruments. So syahi is the design feature, and it has to be done with great care. And you know, almost 100 layers of the material is put on the membrane by the master craftsman. I mean, this is the kind of the highly skilled work. The same syahi also appears on one of the membranes of akauj and also mridangam. So syahi does appear in other composite drums also. So that will be one of the drums that I'll be focusing on. Then I'll move to relatively less known drums. I mean, many of you may be familiar with it. It's a drum which today is mostly played as a temple instrument in Kerala. It's called idakya. But some of the most beautiful sculptures of idakya actually are in Alibudu and Belur, for example. I'll show you one of the most exquisite sculpture of idakya. But idakya has appeared in sculptures from a very long time and all over the place, South Asia, Southeast Asia. So I'll come to like idakya and very interesting features of idakya also. So those who are not familiar with idakya will be very surprised element. Then I also make this distinction of, you see tabla, which is like a monofacial drum. It has only one face on which the membrane is stretched. But you have these bifacial drums. Akauj, mridangam, they are bifacial drums, and there is a sort of a cavity which connects these two faces. In fact, we have had a culture of multifacial drums. I will show you one drum with 5 faces, Panchmukh Padya, which still happens to be played in, I think, particularly in one temple in Tamil Nadu. And I will show you that drum also. But there were traditions in which, for example, even these bifacial drums that you're seeing, there would be a third face in the center. So there were drums of those kinds also. So multifacial drums were also quite common. One other drum that I'm going to focus a bit in this talk is this large drum, and again it is part of the drum ensemble from Kerala, a temple drum ensemble from Kerala, Miral. And again, those who have, for example, seen these Sanskrit drama recitals or performances in Kerala are probably familiar with Miral. It's a large pot drum, very impressive, has a huge personality of its own, and I will talk about Miral there. Okay, so I'll start with these drums with composite membranes, and just to sort of set up the mood a bit, just play some sounds. Tabla. So tabla, particularly when you hear tabla, one of the distinguishing sounds of tabla is this metallic sound, which is essentially coming from the iron paste. If you make this paste of some other material, as was the case early on, then sound would have been different. But there is something else about tabla sound, which is what I want to focus. It has a lot of, for instance, it is a drum with a definite pitch. What do I mean by that? It has a certain melodic character to it, and I will quantify it more clearly as I go on. But let me also just sort of impress upon you the sound of akauj, which is a magnificent instrument, and which usually appears in Hindustani music with Drupad. So I was talking about Drupad yesterday, talking about Rudraveena, etc. So akauj is what accompanies Drupad performances. Listening to akauj live is much more mightier than this. And okay, so let me just sort of get this thing right away. So what I'm trying to show here is this these vibrational modes of string, which is fixed at 2 ends. You see the string shown in that picture. This is a very basic picture. I think most of you must have seen this picture in some elementary physics course or something. It's a very well-known picture. What these 6 vibrating modes are showing that so what happens that you try to vibrate a string, okay, that general vibration of the string, the general shape of the string vibration can be decomposed into several modes, okay, typically infinity mode, like infinite modes. These are the first 6 of those modes, okay. And the interesting thing about string vibration is that if you try to calculate the frequency associated with these modes, this F actually depends on like in the most elementary model of taking these as string-like objects, then it depends on tension and the density in the string. So the interesting thing about strings is that as you can see, as I have written, the frequencies associated with these modes are all integral multiple of each other. And this actually in some way is the reason behind the musicality of string sound, string vibration. I mean, you can vibrate a random string, not really associated to a musical instrument also, and it sounds musical, it sounds good. Okay, that sounding good is basically because of this harmonicity. This, on the other hand, when you compare with circular membranes, so if you think about the same situation now, you think about a circular membrane fixed at the end, clamped at the end. And again, if you look at, for example, here I'm plotting the first 9 modes of membrane vibration. Again, the way you should think about it, basically if you see a membrane vibrating, basically these are the 9 components of that. I mean, if you add these up in a certain weighted way, you get certain membrane vibration, okay? And again, I mean, these are infinite. I'm just showing you the first 9. The most striking feature here is that the frequencies associated with these modes are now nowhere integral multiple of each other. In fact, these frequencies are what one obtains as the roots of the first Bessel function. That is actually how the Bessel function was introduced. I mean, in the first place itself, in the context of drums, in the context of finding frequencies of drums. Okay, that is how Bessel functions were introduced primarily. Okay, I mean, in the first instance. So this is a striking feature, and that is why it is not surprising that when you hit a circular membrane, I mean, a drum, usually a regular Western drum, you don't really hear a musical sound. I mean, you hear a sound, you hear a thump, you hear a thump to it, but there is no musicality to it. There is no melody to what you're hearing, right? There is no definite pitch associated with the sound of the drum. Okay, so this is the status. This is the status of a regular drum, so as to say. Okay. Very interestingly, and this is almost magical, and this kind of tabla, of course, I mean, those who played tabla, those who heard music, Indian music, it was not a surprise to them, right? I mean, tabla, the people who hear Indian music, they would always know that, okay, I mean, when you hear tabla sound, there is melody to it, there is a musicality to the sound of tabla. But it was C.V. Raman in 1920. Who in fact was the first person who showed experimentally why that is so. So he conducted these very careful experiments, and I'll show you a glimpse of those experiments in the next slide. And what was also interesting, that C.V. Raman was working very actively in the field of acoustics and had already written lots of papers to do with violin, harpsichord, whispering galleries, but had not ventured into Indian musical instruments at all. But he writes this first paper, 1920, very brief, publishes in a very good journal. This 1934 paper of Raman is where he gives the results in more detail. Okay, and he conducts experiments. He used Chladni patterns to distinguish the modes, calculate frequencies, and this is what he finds out. If you see the experimental results, you see here I am writing the frequencies of the first 9 modes, and you can see how the frequencies are showing up. I mean, they are all sort of scaled with respect to the second mode. The second mode, if you think about the frequency to be 2, then how they scale. Okay, so these are the ratios, frequency ratios with respect to the 1-1 mode. So this is striking, right? So from what I was showing you in the previous slide, where these numbers are nowhere connected to each other in terms of a harmonic integral relationship, suddenly there is this magic almost which happens in tabla, right? That you have this sudden alignment of modes, and you have this, I mean, of course you have a lot of degeneracy. I mean, several modes are degenerate, they have the same frequency, but you see that you hear at least five overtones, 5 harmonic overtones, and this is what is tabla sound. Okay, the C.V. Raman, of course, was also smart enough to give the reason for this thing to happen, and he clearly says that this is happening because of this particular design intervention of patch, of this well-designed patch. Okay, it was not until 1954 where at ISC B.S. Ramakrishna in the Department of Electrical Engineering took upon to actually prepare a very simple model of just a membrane with a patch. Okay, it is a model where you think of this membrane as having piecewise constant density. In the patch it has a different density, and outside the patch it has a different density. And then he calculates, and of course you have to tune the model a bit, and these are the results. So when I say composite, basically the results of the composite membrane. Of course you can see that there is a gap between them. I mean, this gap is further, I mean, it will be sort of further reduced with the effect of the air cavity. I mean, in this model of Ramakrishna, the effect of the surrounding air, the air cavity behind the membrane, those are not included in this model. Okay. This model was further improved in this another very interesting paper by Adhikari, who used to teach at IIT Madras until a few years ago. So this is a very iconic picture of Raman, where what he is doing is, some of you may be familiar with Chladni patterns. Basically, you just sprinkle some sand on the vibrating object, and you try to tune, you try to play a certain frequency, and at the frequency corresponding to a particular mode, that mode shape will appear, because the sand kind of accumulates at the nodal place, because nodes are where there is no vibration. So sand kind of accumulates at those places, and you clearly see, so that is how you get frequencies associated with these modes. So this is from an experiment of C.V. Raman, and you can gauge the importance of this experiment just to show you how important this result was. This thing what I'm showing you, this first picture, is basically a cover page of a book which collects the top papers in musical acoustics in 20th century by none other than Rossing. Rossing is still recognized as the authority in musical acoustics worldwide. So he collected these papers, the sort of, and it's a small collection, it's not a very exhaustive, I mean, it's not like a thick book. And you see this on the cover page. Okay? I mean, it's, so that kind of shows the importance of this work. Of course, what I'm showing here is just to impress upon you is that for Raman, acoustics was a big area. So it forms the whole volume of his collected works of papers. Okay. So just before I talk a bit more about tabla, I also want to just get back a bit to timpani and tell you why timpani gets some respect in the Western world. What is interesting about timpani, so timpani is this instrument that you see there. The most striking feature about timpani is its air cavity. So it has this big bowl, hollow bowl. This air cavity kind of provides a very sort of roughly speaking, it provides a certain stiffness to the membrane and a certain mass also. So it is like an added mass and added stiffness to the membrane. And what it does in terms of frequencies is, if you see, I've just, I mean, if you don't worry about anything else, just look at these highlighted values. This is what you get. So in a way, you get some harmonicity. So if you think of the second mode as 1, then you get another mode with 1.5 and another mode with 2. So you get some pitch, you know, you get some harmonicity, but that is it. And this has been a study of starting from Rayleigh until very recently. This has been a matter of great study in the Western acoustical studies, who were wanting to show that, yeah, I mean, this is something very deep about timpani. But when you see in the context of tabla, I mean, or many other Indian percussion instruments, this looks quite elementary to say, so as to speak. Okay, so coming back to tabla, I also just want to show you how tablas, how the two tablas, so there is a baya and a daya, right tabla and the left tabla. The left tabla is mostly a bass tabla, and the right tabla is where all the playing is happening. So, but they're very different in design. They're not similar, and anyone who has lifted a tabla would know that. So the left tabla, the bigger one, the baya, is hollow. The shell of this left tabla could be wooden, could be made of clay, could be made of metal. Okay. The right tabla is always made of wood. In fact, the way right tabla is made is you take a solid block of wood and you kind of take off a certain part of it. So this thing is just sort of taken out of that. It remains a solid piece of wood. Okay, this is very unusual for a drum. Okay, I mean this kind of drum design itself is something I have not encountered in my various explorations of various drums around the world. So this is something that I want to just you to keep in mind, and what I would show you some results. This is how actually I got started in musical acoustics. My first paper on musical acoustics was intrigued by this kind of thing. So this is something I did in 2017, and that was my initiation into this world, is to understand. For example, on one hand we saw that in timpani it is the air cavity which actually plays the central role. That is the innovative design feature in timpani. Very well designed air cavity which is giving you these two kind of harmonic modes. In tabla, however, all the action is happening because of the siyahi. So I was also curious to find out what exactly is the role of the air cavity in tabla. I mean, it has no role or it has a specific role. So that is the question that I answered, and I'll just show you that answer very briefly. So first, in the context of right tabla, daya, where the membrane is at the center. In the baya, in this bigger tabla, you see that the patch is actually off center. Okay. In the right tabla, what the air cavity does, it has a very minor effect on frequencies. So if you compare, so this table is the table without air cavity. Actually, see, even without air cavity, you can still have considerations of the surrounding air. The surrounding air will also put some loading on the membrane. So this column is the column of frequencies, just the membrane. This is the column where the frequencies are corrected, accounting for the ambient air, and this is the complete simulation. I mean, it is basically as the tabla as it is, in ambient air and this air cavity also. Not much happens. I mean, the frequency ratio is correct a bit, but not much happens. Okay. What actually happens? The reason for this air cavity shows up when you try to also understand the decay times. So, for example, decay times is when you strike the tabla and several notes get excited. Now these notes take their own time to decay. Now, of course, when you play a certain stroke, sometimes several unwanted notes also get excited. So what happens, and this is something what we noticed, that what is happening because of this designed air cavity, that some unwanted notes get very quickly decayed, while the notes which are central, which are wanted, they sustain longer. So that is the kind of way that we could see the importance of the air cavities that are appearing in tabla. And this is the result for the left tabla. Here actually air cavity plays a role in correcting the stiffnesses quite a lot. If you just see the frequency ratios without air column, I mean, you will not actually see much harmonicity here. It is essentially because of the off-center patch. But it is only when you bring in the air cavity, and here air cavity is quite significant, you actually see some correcting of frequencies to become more harmonic. And again, there is a consequence on decay times also. Okay. There is another very interesting question which comes up, that how do we know that this is the optimum design of tabla? For example, so I mean, you have this patch, right? I mean, how do we know that what is the optimum density or optimum radius of this patch? So we did this small optimization problem where we took a very large problem sort of solution space, and to our surprise we found out that the designs of tabla actually correspond to sort of points where, so this, I mean, the optimization function was we wanted frequencies to be as harmonic as possible, and it turned out that the places where frequencies were as close as to these integral multiples are basically in the parameter space within which these tablas were being designed. Okay, so that was something interesting, I mean, to us, that that it is actually an optimal design. Very quickly moving on to Pakhawaj. Pakhawaj is very different from tabla. So all this story is about Amir Khusro breaking the Pakhawaj in two halves and getting tabla. I mean, I don't know how will he break this half into two parts and get tabla. There is absolutely no way one would get tabla by breaking this into two halves. That is a different instrument. And now several sculptures, even several texts have shown very clearly that there were these monofacial drums played the way tabla is played. In fact, I was showing you this sculpture yesterday. I mean, I'll show that at the end also today. So please don't buy that anymore. I mean, it's very rationally speaking. With Pakhawaj, what is interesting that one side of the Pakhawaj you have this patch. On the other side of Pakhawaj, what the players generally do is they prepare this some kind of dough basically, very similar to what you would do to prepare a roti, for example, and they paste this freshly prepared dough onto the face, and they have these recipes are supposed to be very secretive, and different gharanas of Pakhawaj players, they kind of guard these recipes very cautiously. But this is done on site, and when it dries, it looks very weird, but it is interesting. I mean, and this is a very traditional practice. I will talk very briefly about where this patch is coming from historically, and this is how traditionally the patches were also mentioned traditionally. Now in Pakhawaj, of course, the science is very different, because now you have these two composite membranes talking to each other. So not going too much into detail, but what would happen and what happens is now you will have these modes where the two membranes are talking to each other, and also you will have modes where these two membranes will not talk to each other. This gives a very rich spectrum of results compared to tabla. So the Pakhawaj sound or mridangam sound that way is much more rich in overtones, etc. Okay, so I'll not get into details of this, but just to point to this feature that there can be this coupling of modes between the two membranes, and also this decoupling of modes between the two membranes. This, of course, is a picture from your campus. It's a very beautiful pond that you guys have. So this is actually very interesting. So when I mean, as I was doing yesterday also, right? Again, I got really curious about where does this patch come from. I mean, if this is a central thing to these composite membranes, how far does it go? And interestingly, this is very clearly mentioned in no other place than Natya Shastra. So Natya Shastra, as I was mentioning yesterday, is a very detailed text on very different aspects of Indian aesthetics, very important and very well done text. So in chapter 33 of Natya Shastra is actually on Avnadvadya. That chapter is titled Avnadvadya. I mean, it has several chapters on musical instruments. The first chapter is on Tatvadya, the string instrument, then you have Avnadvadya, then the Sushirvadya. So in this chapter on Avnadvadya, he starts with a story, and the story goes on like this, and it's fascinating. The story is like that this particular saint, Swati, he goes to take a bath in Lake Pushkar, and it starts to rain, and the lake is covered with these pods. And he hears the sound of drops falling differentially in the pond and on these leaves. And he gets this idea to construct a drum, and he rushes back and he constructs this drum. And then the chapter says very categorically that they will be talking about only drums on which a paste has been applied, a paste is applied on the surface. So they, in this text, they use the term margina. The surfaces, on these surfaces you do this margina, the applying of a paste. And the chapter deals with only those drums on which this paste has been applied. The text mentions that there are lots of other drums, which is of course true, but they will focus only on those on which margina has been done. And I find this fascinating. And of course, it gives this detailed recipe. I mean, it's actually amazing. I mean, it spends several paragraphs detailing the recipe on how to prepare that paste. You get sand from bank of this river, you mix this, you mix that, and the paste is prepared. It's fascinating to me. I mean, I don't know if someone has tried to make that again. It'll be interesting to make the paste according to that recipe. What is also interesting, another thing because I'm pausing here, I'll just point to Natya Shastra, that it also classifies these bifacial drums in very interesting ways. So it says that there is this one family of bifacial drums which looks like the end of a cow's tail, that shape. Then there are these bifacial drums which look like grain of a rice. Then there are these bifacial drums which look like grain of bajra. It's a very interesting way of telling you of the shapes of these bifacial drums. Okay, anyway, so this is where I changed the gear. Okay, so now I talk about this, so that is about these drums with composite membranes. So there is some idea, I mean there of course the identifier, the main design intervention is this patch, and with very long history, and that patch is, and it's amazing, I mean such inhomogeneous composite membranes do not appear anywhere in the world culture. I mean even after a lot of inter-exchange of knowledge, etc. I mean I don't know the reason. Anyway, so now we start to talk about Idakya, and this sculpture obviously is very close to you. It's in Helabidu. It's very beautiful. I mean, the photograph has not come out very well. It's a very well done sculpture, and this is where Idakya is played. Unfortunately, what is not very clear in this picture because of the missing part of the hand, that how this is being played. So the modern day Idakya, as I will show you in this video, is played with a stick. While there are also these other hourglass shaped drums or these waist drums. These drums are broadly known as waist drums because they are like held onto your waist. They were played also with hand. First let me just play the sound of Idakya for those who have not heard it. Okay, so I think first, what is interesting, sometimes I have played this sound to people without telling that it is coming from a drum, and most commonly people say that it is a string instrument. Many times they have told me that it is like a string instrument. It doesn't sound like a drum, but it is a drum. I mean, it is like this. I mean, it is exactly. I'll just play this, and while I talk about it. So it is. I mean, it is just playing in very slow motion. So what happens while playing this drum? I will show the parts in detail in the next slide. There is this hourglass shaped shell here, and the two membranes are attached to it. They're not fixed like in pakhavaj, or I mean they're actually detached. They're not sticking. I mean the way they kind of the reason they kind of are sticking to the two faces of the shell is because of the way these rope. I mean actually this is just one rope. This is just one big rope. And that one big rope has been knotted. I was talking about knots earlier. Very interesting knots appear here also. So the same big rope has been knotted and to create this mesh of structure. And that is what holds these two membranes. I'll talk more about these parts. So what is happening is that with one hand is controlling these ropes, as well as, I mean you can see that his hand is on the shell, as you can see here also very clearly. The hand is on the shell. They try to push down the shell. Essentially what they're doing is they're trying to change the tension in the membrane. That is what they're doing. So this is a very interesting drum in that sense, that continuously while playing you can moderate the tension in the membrane, which obviously is not possible. So it's a very interesting innovation that way also. And it is being struck on this side. The design feature, yeah. It's jackwood, I think this jackfruit wood, as far as I know.
So is it flexible?
I will show you the parts in the next slide. I think it will become, no, it's a solid shell. It's a solid shell. It will become clear on the next slide. So these are the parts. So this is the shell. Okay, it's a very beautiful instrument. I have it with me, and it's so this is the shell. What happens, and then you have these, actually in fact you see, one of my students did some field work on this, and you see how he is threading, and this is done, I mean usually all of this is disassembled. I mean the instrument is not kept assembled. I mean, like it is kept all disassembled. When you are about to play it, then you kind of assemble the instrument. So what happens? This is the shell. This is a solid shell. I mean, as you can see from the edges are not sharp. I mean, there is a finite edge here, which again is an interesting problem. I mean, in the context of finite bridges that I was talking about yesterday, because here again the membrane is kind of wrapping and unwrapping on this finite edge. Okay, that's another matter. But here, one of the things that I want to bring to your attention, and that is the sort of the soul of this instrument. That is the signature. That is the signature design of Idakya. There are these two strings. If you see here carefully, you see these two strings, right? These were traditionally made of palmina fibers. These days they use some synthetic fibers also here. These strings are behind the membranes. So this membrane, I mean, the membrane is put here. In fact, you can see these nails. If you look at this carefully, you see these nails at the edge of the shell. So these strings will be tied to these nails with the proper tension, and then the shell and then the membrane will be put on the surface. What I would also like to make a note is that these membranes are almost transparent, paper-like transparent. They come from the inner lining of the stomach of cow, of actually young cows, sometimes even babies cows. On the other hand, tabla membrane is much thicker. It is not transparent. It actually comes from the outer membrane of matured cows. Okay. When we talk about Miral's membrane is the thickest that I have seen. In fact, when I received a Miral, the membrane actually had a lot of hairs on it already. So it is very thin from the outer surface. So that itself is a very interesting thing to get into. Okay, so this is actually how it looks. I mean, I'm just looking from the side. Okay, I mean, this is how the instrument looks like. So this is the tunnel of the air cap, this shell. The shell is here hourglass shape. That is why I was also calling these drums hourglass drums. Unlike pakhavaj or mridangam, which are concave, which are convex. I mean, here it is concave. The shell curvature is concave. So here, I mean, you see, and I mean, with enough light behind, you also can see the strings. Okay. Why I am pointing to these strings? Because there are hourglass drums, particularly in folk culture. So this appears, this instrument, Idakya, is played in Kerala, but there is a very similar looking instrument called Huduka, which is played in Himachal and Uttarakhand as a folk instrument. But there, in many of those instruments, this string, I have not found this string. Okay, and that's why the sound is very different in those instruments. So we got very curious about it. There was no prior work on this. What I was told that the sound is very musical, that people could play a lot of melodies on Idakya, and that got me very curious. So the first thing we did was to just record the sound and just see the spectrum of the sound. And to our surprise, and of course, I mean, partly not to our surprise because the sound was very melodious, you see this very large number of harmonic modes. All these red lines are the modes, and these frequencies are actually all harmonically related to each other. I mean, these are much larger number of frequencies harmonically related to each other than the composite membranes, actually. Very large spectrum. I mean, if you remove those strings, so we did the recording also without strings, and you see the whole structure disappears. So this is the same instrument played exactly in the same way, except for the strings not being there. So the instrument dies in some sense. I mean, this is not the same instrument. This is the instrument, and you see that it's extremely rich array of harmonic notes. So it's almost like a string instrument. So we got very curious about this, and we were wondering how to prepare the most simplistic model of this. So what we ended up doing was to just consider a clamped membrane and two of these fibers and some kind of coupled model. Okay, and just this itself resulted in some very interesting things. And you see how the membrane kind of wraps around, the string wraps around the membrane in some ways. I'll show you two videos here. But before I switch this on, what I also want to point out that there are snare drums in the Western culture. So they're usually part of the drumming ensemble. There are these marching drums, and there are snare drums. I mean, if you search for snare drums, you will find snare drums. But those snare drums are not musical. Okay, And this is what I'm trying to explain here, because you will see. So there also you have these snares, these these strings below the membrane, which interact with the membrane. But here, because of the material of the membrane and of the string, the interaction is very different. And this is what I want to point out. And this is the differentiating factor, okay, which changes everything. So let me play it first. I mean, these values are exaggerated, okay, so don't, I mean, the real vibrations are, of course, at a much smaller scale. So what you see below is the string, what you see above is the membrane. So, so here you see that it is kind of almost like wrapping and unwrapping around, the string is trying to wrap and unwrap around the membrane. Here it is very different. Here it is almost, I mean, here it is impact. I mean, again, the values are very exaggerated, but just to make the point, okay? So this is what is happening in these two instruments, and with very different results. There are no harmonic frequencies in the Western snare drum, absolutely no. I mean, also to show you what is also done in terms of energy transfer to higher modes, etc., and the sustenance. This is how, so this is the situation in Idakya, and you see that blue is the mode that you excite. For example, the fundamental mode, which will get excited if you hit the membrane on the center, which is what is usually done. What you see immediately that if you excite the fundamental, a lot of these higher like overtones also get excited. So energy gets transmitted to these higher tones, and that is, you need these overtones for musicality of the sound. That doesn't happen here, you see. I mean, although the sound sustains a bit more, but there is hardly any energy transfer to higher modes. So if you're interested in this, we do some analysis on this in our paper, etc. These are again numerical results. I mean, just to show you very convincingly, these red lines are harmonic sort of relations, and all the peaks pretty much fall very closely to on these red lines. So there's very interesting harmonicity. There are very similar drums which appear in other cultures. I mean, this is Suzumi. This is a very popular Japanese hourglass drum. And this is a talking drum, which is again a very well-known talking drum from Africa. But none of them are musical. Their sound, it doesn't have harmonic frequencies. They don't have snares also. Okay, so they look very similar, but they're very different sounding and very different drums. Just to sort of draw in comparison. Talking drums are of course used for a very different purpose altogether. I mean, for those who don't know about talking drums, very, very innovative, and they're almost like communicating devices. People use them to talk across mountains. They have developed a whole language to talk to each other, because they can't shout. You can't shout across a mountain, but people drum across a mountain, and they're able to talk to each other across a mountain by the language they have developed on these drums. So yeah. Okay, so this is the final drum that I'm going to talk about, and I find it most fascinating for many reasons. This is Mirab. Mirab it has been prohibited to put on ground. So Mirab is never put on ground. In fact, it has come out of temple very recently. There was a lot of resistance from the Mirab players who belong to a very particular community, who had a very particular role. And only very recently it has come out of temples, and you can hear Mirab now as an instrument. It's a very old instrument and very simple instrument. It has this big pot which can be metallic and which can also be made of clay. And all that you do, you take this really thick membrane. I mean, this is also a membrane. I mean, this is the same membrane which comes all the way here, and really thick. I mean, you have to see this membrane to really appreciate how thick it is. And as I said, when I got this instrument, I mean, the top surface was full of hairs. We literally have to shave off the hairs from the surface, and like, it is very thick membrane. And what they do is they stretch that membrane, put it there, and really tie it very hard. Okay. Of course, you can see. I mean, the first thought that came to my mind when I saw this instrument. Okay, I mean, is this something like Helmholtz resonator or something like that? But I approached it from that viewpoint and didn't go anywhere. But then I did a more careful modeling, and I'll show you. So essentially, the importance here is of this big cavity. So these such drums they go by the name of pod drums. And again, pod drums are also very common all across the world. It's just a very big pod drum. I mean, that is the differentiator here. This is how Mirao is played. There is a frame that is kept right behind this. I'll actually show you a performance, a short clip from performance where Mirao is being played. And the player also sits behind the instrument. The instrument is greatly respected. And again, as I said, it is never kept on the ground. In fact, this is the only instrument, there's a very interesting thing I want to share with you. When you start to learn to play this instrument, you don't actually get to play on the real instrument until much later, after years of exposure to it. So there is a practice Mirao, very interestingly, which is which is actually just the top part of this Mirao, kind of just a practice instrument. I mean, the learners play on that for years, and only when the teacher thinks that, okay, this guy is now well trained to play the real Mirao, there's a whole ceremony, and only then he is allowed to touch a real Mirao. I don't know of this kind of thing with any other instrument in the world, that you spend years actually not playing the real instrument, and suddenly and after you supposedly become good at the practice instrument, now you can play the real instrument. So I have both the practice Mirao and the real Mirao. So this is also very close to you. This is I checked that this place is also very close to Hassan. Very, I think within 60-70 kilometers of Hassan. And here you see this interesting pod drum, right? You see it has several faces, and this kind of pod drum is there. And there are other instruments here also. Another drum which looks very similar to this, and this appears in a lot of sculptures, is this five-phased drum, which I find fascinating. And it's, just to read more about it is quite. It's called Panchmukh Vadya, and it's not a very clear picture. This is from this Nataraj temple in Chidambaram, and there is still this one temple in Tamil Nadu where there is one family who knows how to play this drum, and they play it once in a while. So this is still there, and I see its connection with Mirao to some extent. This is actually the way even the membranes are put here. So the membranes of this come from skin of an antelope, and it's very interesting. The different membranes come from different parts of the antelope skin. So for example, it is well prescribed that this has to come from certain area, and this has to come from certain area. It's very interesting to see this construction of this. Anyway, coming back to Mirao, let me just play this performance. Just see in a minute. Very short performance. So you see, the performance is just backed by these two instruments. There is nothing else, right? And that is the importance of Mirao. It actually, the reason it is part of the storytelling is because sound is compared to the roaring of lions, the thunder of the cloud, and things like that. It has that kind of thing. So again, I got very curious about what is this sound, and what is the signature of this sound. Why the sound is so distinct. Clearly the sound is not musical, but that is very clear even when you listen to the sound. The musicality is not, this sound is not expected to have that harmonic character. So we did audio recordings and we saw the spectrum. These are not harmonically related to each other. Also, the way this drum is played is in a very straightforward manner. Most of the times you just hit at the center of the drum. So you are only exciting the fundamental, so as to speak. By hitting at the center, you are just exciting that. But clearly what you hear is a lot of overtones. A lot of overtones do get heard. Okay, so it was not very clear exactly what was happening there. And we did some modeling, and these are just the modes of the membrane separately and the shell separately. And this is the key idea, and this is something that I just want you to appreciate. So just focus on these highlighted numbers. So here, we did this study with different tension values in the membrane, but this seems to be the closest to the diameter, and the tension seems to be the closest to the actual Mirao. what happens is that because of the air cavity, you see that several frequencies associated with the fundamental mode. Because what will happen is that the fundamental mode of the membrane gets coupled to several modes of the shell, okay, the air cavity in the shell. And as a result, you see that the 0-1 mode, okay, of the membrane appears at several frequencies. I mean, you can see four of those here. And the 0-2 mode also appears, I mean, actually there are 5 of these, actually, if you see here. And 0-2 mode also appears in 3. This happens, I mean, again, I'll show you a comparison with some other large drums. This is a very unique aspect of this drum. That because of this very uniquely designed air cavity, we are able to generate these very basic modes, 0-1 and 0-2, in these multiple frequencies. And that is the reason of this overtone rich sound. I mean, these frequencies kind of match with those frequencies that I was showing you earlier. But this is kind of the signature of mid-off sound, right, that I want to point out. This is not usual at all. For example, if I compare the sound with nagada, nagada is another big drum which is used mostly to make announcements, and that is why the frequencies are low, because you want to reach out farther. But again, if you see nagada, I mean, no, I mean, it's just 0-1 mode, 1 frequency, 0-2 mode, 1 frequency. Also timpani is another big drum. No, I mean, we did not see this multiplicity of frequencies corresponding to the same membrane mode with any other large drum. And this, we realized, is the signature of the sound of Mida that is coming. That is what we are. So I'll end here. This again is the same picture that I showed you yesterday, but now of course our focus has shifted onto drums, and there are these convex drums here, and also there is a drum being played in the lap. But so this is where I'll end the talk today, and again I'll be very happy to take your questions.
Thanks, Anurag.
Yeah.
Questions?
At the top structure of Tānpurā, there is a patch in the center, but there is another membrane that covers the membrane.
Yeah. So there are actually this membrane that is which you play is actually sandwiched between two annular membranes, membranes with a hole. So there are two membranes, one on top which you see, and there is one below. The idea behind them is they kind of dissipate some unwanted higher modes, because as you see that in tabla, it's only the first 8 or 9 modes which are sort of in harmonic relationship to each other, and that's why musically sort of interesting. So you don't want these higher modes to show up, and that is what those two membranes are kind of doing. They're kind of dampening down these higher modes which may be appearing.
Also, I know how to play tabla. Some of the notes are played on that edge that is folded, and you don't hit the center.
No, but that is only striking. See, what you see in the frequency spectrum is any striking will be decomposed in terms of these modes, right? So wherever you strike, I mean, people strike on those are the different sort of notes, sort of bowls of tabla, right? Where you strike, how you strike. So striking is the excitation. The modes are basically, any excitation will be broken down in terms of, the response will be broken down in terms of these, the modes that I showed you. Okay? Yeah.
There is another instrument called chanda.
Chenda, yeah.
Is that also a snare drum? Because
No, chenta is not snare, but chenta has a very unique construction. Chenta has 7 layers of membrane. There are like the membranes. There are in 7 layers, and membranes are of also different material. So I have not looked at the acoustics of chenta, but it is it's another Kerala. Another drum in that ensemble temple. This ensemble that is very interesting, but very different.
but that also have overtones, right?
I don't think so. I don't think chenta is a musical instrument. I don't think it has that. When I say musical instrument, it has this harmonic overtones. From whatever little I could be wrong there, but from what I have heard and what I have been told, it doesn't have a lot of harmonic overtones. But I could be wrong.
What you played for Ilaka sounded very similar to an instrument that they use in Teyam, some kind of performance that they do in front of temples or in homes.
Where?
Teyam. Tayam is some performance that you do.
But in which region?
Kerala.
So then they might be playing Idakya, right?
No, it was much larger.
Oh, then it is Chenta. But
So
they
that
may
was-
be, my guess would be Idakya might be hidden somewhere. I mean, usually they play Idakya and Chenta kind of, they're playing, Mirab is usually, usually in some of these performances that I was showing you, like Idakya also turns up. It's usually Mirab, but Idakya turns up. But in many of the kind of performances that you're talking about,
Yeah.
they're actually playing Chenta, Mridangam and Idakya, all of them.
There's one at the back first.
It's a basic question, and probably I missed few parts, so
Yeah.
I'm asking again. If you look at the musical drums and non-musical drums, what distinguishes basically is the multiplicity of the frequencies?
Exactly. This harmonic relationship.
Okay, so about the harmonic relationship, is having more harmonics preferable or less? That I couldn't follow.
Yes, so if you have, like for string, right? String, all the modes have frequencies in harmonic relationship. All the infinite modes. You're right? F, 2F, 3F, NF. So string is very, very musical. So that is kind of the thing. But here, of course, you cannot, in none of these drums one can achieve this large amount of harmonicity. But you get this content, so that's why there is a certain set of modes which you are able to get into harmonic relationship, and that is the limited scope in some sense. So obviously they can never become as musical as a string instrument, but they try, and that's the idea.
So I have two questions.
Yeah.
One is with respect to the tabla.
Yeah.
Now you can produce different pitches on the tabla.
Yes.
Is it when these different pitches are related to the energies that are in
Yes.
various modes? Or
Yes. So the idea of pitch is a very, it's not just frequencies, as I'm sure you would know. So many people think that pitch is just a frequency spectrum. So it is much more than that. And I think energy, the way energies are distributed between different modes, I think all that has to be taken into account. But it's not something I have delved into deeper, so I cannot answer it very confidently.
The second question is you speak of different materials used
Yeah.
for the patch.
Yeah.
So, you have any idea of what materials to use and any kind of match with the sounds that they may have been in?
I don't know. I think, so as I said, presently it is, the black patch is iron paste, and that's why you hear this metallic sound. And in Pakhavaj, you see this other side. Somehow that has survived. Interestingly, that has survived. And that way of putting this patch, which is how these traditional texts actually mention that how this paste has to be prepared and put on the drum. But so I think one can study that. I've not done that kind of study with respect to Pakhavaj.
Swati.
Yes,
picture
yes,
that you
yes, yes,
and the pond.
yes, yes.
So, you say that the
Pods are like patch.
Yeah. No,
Yeah.
or the sand from some areas. So
No, that is a different thing. That is a different story. That is a prescription for how to prepare the paste. So that is so. This is like mentioned as a story on how he got motivated to prepare the drum, to make these drums. And then there is this different. That then it gets into technicalities about how to make these. How to make this patch.
My one question is that is Miraval or Ilaka, are they ever used as accompanying instrument or
I don't. So this Miral is, has been mostly used in this Kuriyatam. I'm sorry, what I showed you was a Kuriyatam performance. I don't know of where else have they been used besides these Kuriyatam performances. And Kuriyatam performances, they are sort of the main focus. But other than that, but now I think people are trying. For example, I think someone told me that there was a series on Prime Videos with A.R. Rahman hosting the series, and apparently the first episode of the series was centered around Mirao. So he kind of jams with someone playing Mirao. So, but I think they're trying to bring it up. But Iraqia, again, I don't know if it has been played on, as accompanying instruments.
Yeah, thank you for the talk.
I just wanted to know, have you been able to share all of these results with say instrument makers, or and what has been their
I mean,
responses?
I have to first find that much value in these. I mean, they also see this. There are many things there, right? I mean, this is just my I'm trying to understand many of these things. I mean, there is no goal of that sort. Much of this work has been done, just to understand what is going on with these instruments. I think what you're saying can happen when I also feel confident about many of the things, and then I can go and talk to them. But I mean, what I think kind of I try to understand is that they do possess, I mean this kind of understanding that people possess knowledge of different kinds. And we have to understand that from different perspectives. It's not just one way of understanding knowledge or possessing something. So this is, I have built a lot of appreciation from this whole musical instruments perspective, that people who are making these instruments do possess this knowledge and deep understanding of design. Yeah, yes, sir.
I'm just following up on that.
Yeah.
One of the things that musicians can do is, bring to you the entire versatility of what they can do with the instrument.
Right.
And then that would be useful for you.
Right. No, you're absolutely right, but somehow that dialogue has to start, and for that, first of all, a platform has to be. I mean, the wonderful example of that which comes to my mind is in US. There was this very famous violin scientist, I don't know what you can say, Hutchins. She was, I don't know if you've heard of it. If you've not heard of Hutchins, just search for Hutchins violin. She kind of revolutionized violin making and understand. She did end up working with a lot of violin makers after a lot of resistance. But I mean, I've often thought about it, but there are many reasons. I mean, first of all, this is kind of, I'm anyway spending a lot of time here, which is kind of eating away from a lot of other things that I want to do. And secondly, it makes me go beyond. I always feel very uncomfortable to step out of my office. That is the honest answer, I think. All this I can do within my office. What you're saying, and that is but I guess, I mean, maybe someone else has to pick it up, and I have interacted with, so there is this very bright, there is this guy called Kavish Seth. You might have heard of his mother's name, Kavita Seth. She sings beautifully, some beautiful ghazals and all. But this guy is fascinating. I mean, he's an undergrad from IIT Bombay, and what he's devoting his career to, he's making these very interesting sort of fusion venas between sarod and guitar and rabab and things like that. And I have been very closely interacting with him. He's some guy with, somehow we can talk together and we sort of have some language. With instrument makers, I have tried, but I would need much more time to I would need to spend time with them, I would need to host them. And so what I was thinking of doing, but obviously, I mean, all those things need support, and all this work has been done without support. I mean, yesterday's talk, and because I don't want to bring that element into my sort of. But what would be, I think, great is to bring some of these instrument makers on campus and let them build these instruments on campus and let people kind of see the process. And then, when you do this as a participatory process, then, let them also appreciate some kind of viewing and let us also appreciate their making.
No, I mean, I wasn't thinking of just the instrument makers, but also the instrument players.
Okay.
For instance, Zakir Hussain shows all the range of
things
you can do with the tabla, sound like this or that.
Exactly.
Exploring the
Right. I have not explored that too much. I have spoken to, because we do keep getting musicians on campus, so I talk to them and they show a lot of interest, but I have not followed it up really. It's something.
Thanks, Anurag, for
the question in the back, sir. Sorry.
Yesterday and today and sharing classic knowledge.
Yes.
Otherwise, I would have never understood.
Thank you.
But my question is, I found the numbers for the frequencies you showed.
Which ones?
The low ones and so on. I didn't find much of an effect of the tension in the membrane.
No. Which drum are you talking about?
Previous
This drum. This one.
All the frequencies were pretty much on the disturbed even though you took up the tension from 3,000 all the way to 4,000?
Yeah.
Is there any scientific explanation?
Yeah, I mean the 4,000. I mean what we see on a real mirror,
Yes.
the tension is close to 4,000.
But the frequencies haven't gone up the square root of 1.5. I was wondering whether.
No, because it is not just the membrane right now, right? The air cavity plays a lot of role.
Not that T by rho.
No, of course not. Of course not. It is much. I mean, now it is the full system, right? So these frequencies are not frequencies of the membrane. They are frequencies of the full system, which is the membrane and this massive pot, which has the shell and as well as the air cavity. So we model the shell also and the air cavity also.
Thanks.
There is some research or some work being done for changing from the animal skin or hide to synthetic material.
Yes.
Now, does that make any difference or any comparative studies or anything available or you're aware?
Actually, it will be interesting because all this modeling, it doesn't really account for the material because it's a very zeroth order model where I mean, none of this modeling uses any material properties. All of these results that I showed you just basically uses density and tension. Those are the only things, and you assume that tension is uniform in the membrane. Those are kind of higher order effects, and but obviously I'm sure they play a role because music is not just these frequencies, right? Music is a lot of other things also, like timbre. I'm not talked about timbre. I've talked only about a certain aspect of the musical quality, which is, I mean, a very narrow quality. I mean, there's a lot more to musical sound than these frequencies. And I think the material nature plays a role there. But what you're talking about, I have actually heard and I have actually seen tablas, wonderful tablas actually, being prepared with mylar skins, mylar membranes, and doing very well actually also. So, but yeah, I think going forward maybe because these animal skin membranes, on one hand, if you see how they are prepared and the kind of hardships the people are facing in trying to get to it, I mean that is one aspect. So maybe these mylar membranes can help that, and obviously even the tuning and the resistance to weather and all. It becomes a challenge to maintain these instruments because of the animal skin there. So those could be things in the future, but people are, I know, and things are looking very promising in my opinion.
Thank you for the question. I think we'll just wrap here and we'll continue this over refreshments, but I just want to take a moment to thank Anurag for the last 2 days. Thank you. Thank you. We hope you join us for refreshments in the amphitheater in that direction.